This short training will describe how polar hyperspectral data can augment ABI information or AHI information and produce a better forecast. This is work that has been done by Bill Smith and Qi Zhang at Hampton University. Bill Smith is also associated with SIMS, and by Elizabeth Weisz at SIMS. I'm Scott Lindstrom from SIMS. Retrievals that are extracted from hyperspectral data yield information that is far more useful than individual radiances from the bands. Techniques have been developed to create retrievals in cloudy conditions for non-opaque clouds. The multiple channels in IASI and CrIS translate into vertical resolution that is sufficient to, for example, determine cloud heights in cloudy regions. Note the horizontal spatial resolution from these sounder instruments. It's far coarser than the spatial resolution with ABI and AHI, and ABI and AHI have far better temporal resolution as well. Blending the data exploits the temporal and spatial resolution from geostationary orbit with the spectral resolution from polar orbiters. This figure shows the IASI and CrIS observation space overlain on the spectral response function from long wavelengths on the left to short wavelengths on the right. CrIS observations are split into three regions: long wave, mid wave, short wave. Temperature retrievals from satellite are in pretty good agreement with background fields that are typically model generated, so you're comparing it to a forecast. Water vapor retrievals are more likely poorly correlated with the background fields, suggesting that model simulations of water vapor are inaccurate. Assimilating moisture into the model therefore has a pretty positive impact. The strengths of geostationary satellite are good spatial resolution and excellent temporal resolution. The strength of polar satellites is that there is excellent spectral resolution. If you blend the two, you take advantages of the strengths of both. Vertical resolution is related to the number of spectral bands. These weighting functions show where in the vertical the different channels view information. On the left is ABI. There's not a lot of information coming from the middle of the atmosphere. CrIS and IASI have lots of information coming from throughout the atmosphere, so much better spectral resolution leads to much better vertical resolution by those instruments. Gases in the atmosphere absorb at different wavelengths. Carbon dioxide absorbs around 14 micrometers, for example, and around 4.4 micrometers. Water vapor absorbs between 5.5 and 8 micrometers. Sulfur dioxide absorbs around 8 micrometers. The presence of the different gases in the atmosphere means you have different ways to view vertical slices in the atmosphere. This flowchart shows how blending ABI and polar hyperspectral data can be achieved. You are relating the ABI information to polar hyperspectral data at the same time. This helps you use ABI data and pseudo-PHS data at times when polar data are not available. In other words, you've established a relationship when the polar hyperspectral data are there with the ABI channels. And then you can back out what the polar hyperspectral data would look like if it were there when it's not there. Polar data can alter the initial fields. This can be especially important where clouds are not present because small-scale variability in the moisture distribution that can be important as convection develops can be observed by the polar hyperspectral data. You won't get a lot of information underneath thick clouds, but you will get information under non-opaque clouds and in clear skies. The polar hyperspectral sounding data better defines the moisture distribution in the atmosphere and has a positive impact on the subsequent forecast, especially for cases shown here where the significant tornado potential, STP, is outlined. The STP is correctly reduced outside of where the tornadoes occurred in the model run that's shown on top. This is the one where the polar hyperspectral sounder data is used to better define the initial moisture. Here's a case from the Dayton tornadoes on Memorial Day 2019. 6-hour forecasts were created every 3 hours. Between 15Z and 18Z, polar data would have become available. allowing for a better definition of the moisture fields in the atmosphere. Note how the STP is clustered around the observed tornadoes in these simulations. Things to keep in mind. Note that in contrast to, for example, NuCap soundings, using all channel radiances for IASI or CrIS is important, for the reasons given. There is a website you can visit to view the model output. You can also view model input there. This concludes this training. Thank you for listening.